Welcome to Analytics Nexus 2019, the premier virtual event for analytics best practice. This presentation is titled 6 Data Quality Prescriptions for Machine Learning and will be presented by Thomas C. Redman. This is just one webinar in a whole series of presentations you have access to beginning today. A few quick housekeeping items before I introduce this particular presentation. At any time, you can interact with this presenter or other presenters with questions or comments on Slack. The Slack address for Analytics Nexus is analyticsnexus.slack.com. And you should have received an email invitation to join if you registered in advance. If you didn't receive that email, you can find an invitation link to the Slack in the menu below, as well as in the resource list. Once you log into Analytics Nexus Slack, you can find the channel for Thomas to engage. Also, you can engage with us on Twitter. Our Twitter handle is @analytics_nexus. Finally, for questions on Analytics Nexus or Claravine, which is producing this event, feel free to email us at info@claravine.com. The presenter for this session is Dr. Thomas C. Redman, the Data Doc. He is also the President of Data Quality Solutions and helps startups and multinationals, senior executives, chief data officers, and leaders buried deep in their organizations to chart their courses to data-driven futures, with special emphasis on quality and analytics. Tom's most important article is Data's Credibility Problem, published in the Harvard Business Review in December of 2014. He has a PhD in statistics and 2 patents. Tom, I'll let you take it from here.
Well, thank you very much for that kind intro, Creston. I'm delighted to be joining this Analytics Nexus event, and thanks to the good folks at Claravine for including me. The subject of today's discussion is data quality and machine learning. And of course, machine learning is all over everyone's email. You can't open it without seeing something about machine learning, and so there's a lot of excitement there. And frankly, I was dismissive of it for a long time. After all, there's been many AI winners. But 2.5, 3 years ago, a colleague, Alex Borick, warned me, and he said, "Tom, you have to take a look at this." And so I studied it. It took me a good long while to understand. But when I finally did, it seemed to me, oh my goodness, bad data could really hammer machine learning, and an application could cause real problems. Indeed, we could shut the electric grid down in 20 minutes. I don't mean that literally, but as a metaphor for the damage that could happen. So I began to study it pretty hard in terms of what we ought to do about it. And April of last year, was lucky enough to publish an article called "If Your Data is Bad, Your Machine Learning Tools Are Useless." And that's what I'm going to summarize today. Generally speaking, everybody is in agreement that data quality is absolutely essential for machine learning, that the data is not up to snuff. But so far, progress is too slow. Now, if you're a company listening or trying to chart your course in data, here's my bottom line. Machine learning, artificial intelligence, offers enormous potential. You ought to be exploring it. But bad data can really compromise the effort. Indeed, the combination is potentially lethal. My simple prescription for this is you have to bring everything we have in the data quality toolkit to bear. To quote Warren Zevon, bring lawyers, guns, and money. Put an aggressive program in place, the sooner the better. And in doing this, think about the overall effort, not simply as a data science project, but an overall company effort. Bring everyone into in the company to bear in improving data quality for your machine learning exercises. Now, why the excitement? Now, this graphic illustrates a way of thinking about a difference, an important difference between traditional analytics and machine learning. Most of what we do with computers is we figure out an algorithm. And we take the algorithm and some input data and we run it into the machine, and the machine produces outputs. And then we use those outputs going forward. But what if the algorithm is difficult to develop? So, for example, no one knows how to write an algorithm to recognize cats, and there's lots of things that we don't know how to write algorithms for. What happens then? And this is the beauty of machine learning. Here we can take the input data and some output data, some things that are properly labeled, run them through the machine, and the machine will develop the algorithm for us. It's most useful in situations where we can't code the machine, but this is an exciting, exciting development. This is a big deal. But this question, why the excitement now? After all, backpropagation was invented over 30 years ago. What's different today? And the two things that are really answer that are just the vast quantities of data that companies have been creating and collecting, and public entities have been creating and collecting over the last 30 years, and the vast computing power. Right? Now, what is it the algorithms do for us? The algorithms is sort of an Econ 101 kind of thing. They lower the cost of predictions and, in turn, the decisions that are used. And what does that mean? Right? When demand increases, when prices go down. There's been many small-scale successes with machine learning so far, and those who think big term estimate the potential to be enormous. Say, in this particular study, a 14% boost to global GDP, just 10 or 11 years down the road. So now, let me summarize my concerns. Virtually everyone, and certainly everyone in tech, knows the old saying, garbage in, garbage out. And when it comes to machine learning, we have what I call a double-double whammy. The first thing is, if the training data is bad, we're going to get a bad model, and we're going to get bad results. But even if we do a good job cleaning up the training data, and we create a good model, we still need to use the data going forward. And if there's bad data going forward, we're still going to get bad results. We need both good training data and high-quality data in the application of the model. We also need a good teacher if we're going to be able to get good results. Now, to properly train a model, the historical data must meet exceptionally broad and deep quality standards. I think of it this way. There's two basic kinds of quality dimensions. Is the data right? Is it correct? Right? Is this data, are the facts as stated? And then the second is this the right data? Is the data free from bias? Does it have predictability? And so forth. So there's two dimensions here in all of machine learning, the right data and the data being right. Again, broad and exceptionally deep quality standards to properly train a model. Let's look at this a little bit further. On the right data side, best statistics are that only a few % of data meet the basic quality standards needed every day. And the quality standards for machine learning are far, far higher. Now, on the right data standards, we see a lot of problems. Lots of disparate data, problems with bias, and so forth. And those who are trying to promote a machine learning agenda have to deal with these issues, okay? My next concern with machine learning and data quality is the usual countermeasures don't work. one of the things that you can do in normal analytics is that you can clean up, really scrub a small sample of the data, say 1,000 records, and then you can apply your analytic technique and see what you get, and then you can compare it with the results that you get when you don't scrub all the data, when you simply rinse that data, and if the results are pretty good, then you can say, hey, we have reason to trust this data. But with artificial intelligence, you can't properly train a model with only 1,000 records. So this countermeasure is not available. The second countermeasure that's not available, usually in analytics, we get things like parameters and coefficients, and we can compare those parameters and coefficients to our understanding of the real world. And if they don't make sense, we can move on. But with machine learning, this option is not open to us. Too many of the models lack transparency. My fourth concern gets to implementation. And there, data quality is even more problematic than it is in training. Recall garbage in, garbage out. And 80% of the time that data scientists spend developing a predictive model is spent dealing with data quality issues. After all, this makes sense. Only 3% of the data meets basic quality standards, right? But that kind of time frame, that kind of effort, using the model going forward, really subverts its intention of lowering the cost of predictions. If people are going to have to spend so much time cleaning the data before they can use the predictive model, it's simply not going to work. Furthermore, and the thing that really made me crazy in understanding the impact of data quality and machine learning is this notion of a cascade. Now let's talk a little bit more about what cascades are. Most of the time, people everywhere are wise to the fact that data quality can be an issue, and they expend significant effort trying to catch the errors before they're used. And if they find them, right, then they may have wasted a lot of time and spent a lot of money, but the errors don't leak through. I call those kinds of errors linear errors, caught before they do much harm. The second kind of errors I call exponential, and these are leak through, and they must be dealt with. It may be that you send a package to the wrong address, or a decision is suboptimal, and so forth. These cost a lot of more time and a lot more money, but still, in most cases, the impact is contained. With cascades, this is not the case. The error spins out of control. Perhaps a small error in one predictive model feeds a second predictive model, and there the error is larger. And then the error gets larger and larger and larger, right, as predictive models are strung together. And things spin out of control, right? By analogy, we shut down the electric grid in 20 minutes. Now, these kinds of things have happened. The financial crisis basically is a string of small data quality errors cascading together and causing enormous damage. Okay, so and the bottom line here is unless you take aggressive, proactive measures, the predictive model is going to yield bad results when you turn it loose. And these bad results can multiply and cause enormous damage. So now, what to do about it? I'll devote the rest of my time here with you today talking about that. As I noted before, Warren Zevon had the right idea. Bring lawyers, guns, and money. The first thing that you need to do is you need to have a stone-cold, sober examination of whether or not you have the right data. The second is clean up historical data. Third, you need to bring great breadth into the data preparation and the training of your predictive model. Fourth, address new data quality proactively. It's the new data you'll be using as you turn your predictive model loose, and you want to address data quality there. Get in front of the errors, make them go away. From a company perspective, you need clear management accountabilities for data quality, the machine learn for the predictive model, both the training of it and its use going forward. And finally, independent quality assurance. Get somebody outside your organization to take a hard look at everything you've done. People sometimes ask me, Tom, which of this can we skip? And which of the 2 or 3 are most important? And a word of caution, don't skip any of this. The quality demands of machine learning are far steeper than anything else we encounter. And so you need to bring all of these things to the table. First, provide a stone cold sober answer to the question, do we have the right data? And I want to give an example of this using a mortgage origination company, which basically is trying to answer the question, should we grant the loan, and if so, under what conditions? The available data are 50 years of mortgage applications and the performance of those loans. Now, the company can have different objectives, right? First of all, it can simply be looking to lower costs and not be concerned about making better decisions per se. In that case, the existing data is probably fine. If the mortgage company wants to remove bias, however, this will be a lot tougher. The bias is almost certainly reflected in the existing data. And the data you have do not support this objective. Avoid using these data for this purposes. If the goal is to simply improve the current process, this is a little bit more nuanced. Look at this 2x2 table here. On one axis, the mortgage is either granted or not. And on the other axis, the loan either performs or the loan defaults. And so improving the process means you can either grant fewer loans grant fewer loans that then default, or you can reject fewer loans that will have performed. But note the problem here. You don't have data on the rejections, right? You simply don't know what happened with those. So the data you have are not rich enough to improve the process in this way. The second countermeasure for dealing with data quality and machine learning is do a really, really good job in cleaning up the historical data for training the data. Plan to devote 80% of your time doing this. And the usual things you need to do. First of all, you need the baseline quality levels. You need to repeat that after you've cleaned up. You need to do all the work to make sure that the definitions and units of measure and so forth are aligned in disparate data sets, deduplicate, and then rinse, wash, scrub. Keep on those things aggressively. The third countermeasure is to bring as much depth and breadth as you can into training the predictive model and in preparing the data. Now, a sort of bad news for the company overall, but good news for the predictive learning exercise is that business people have considerable experience dealing with data quality issues. They've been dealing with them for a long time. And so bring them to bear in the development of the predictive model, and then, of course, in turning it use. Laura Kornhauser has stratified in the statement that you can read on the screen, emphasize doing this as soon as you possibly can. Great advice, Laura. The fourth countermeasure is that once you have your predictive model, remember that now we're going to turn it loose, and we shouldn't expect the quality of data used when we turn the predictive model loose to be any better than the quality of the data used to train it, okay? And so it's very, very important that we get in front of the quality problems problems in the data we're going to use. Sometimes I use the analogy that a database is like a lake, and when it comes to cleaning up a lake, you have a couple of choices. First, you can either deal with the dirty lake, or you can work upstream and quit putting so much junk in the lake. So too with data quality. You can either clean up the data, and you have no choice in doing that for training the predictive model, or you can find and eliminate the root causes of error. And that's the key thing that you need to do for the data that you're going to use when you turn your predictive model loose. You need to start that work at least 6 months in advance of the time that the predictive model will be ready to go. Fifth, clarify management responsibilities going forward. You must name a person who is responsible for data quality when you turn the model loose. That person must, of course, attack data quality proactively, and they should set some boundary conditions. So when we're unsure about the data and we're not going to use the predictive model, and also when we can use the predictive model, but humans must assist. My recommendation is that you set the conditions very strictly at first and then loosen them as you gain experience. Sixth and finally, independent, rigorous QA. The quality assurance defined is the process of ensuring that the quality program provides the desired results. The watchword here in the title is independent. You can't do this alone. You're too much into it. Get somebody inside the company skilled in the art to look at your overall quality program, or engage an external consultant to do that. Okay. The other watchword is rigorous. Bend, fold, mutilate, and spindle. Look at everything that can go wrong. So far, everything that can go wrong has gone wrong, at least to some people. So leave no stone unturned. Let me sum up. We've got some tough problems. You can see I've listed them there. Garbage in, garbage out, a double whammy, and then the depth and breadth required to properly train a model. The fact that today most data do not meet even the most basic quality standards. The usual thing we might do in analytics to deal with some quality issues simply don't work with machine learning. And then finally, data quality is just as challenging in implementation as it is in training the model. Fortunately, we have 6 prescriptions or six countermeasures. And importantly, as you start this work, until you gain experience and are really, really good at this, don't skip any of them. So what's my bottom line here? I started with this, and let's close with it. I think that there is enormous potential in artificial intelligence and machine learning. Almost certainly your company should be exploring it. But bad data, at the very least, compromises the effort. And worse, it's potentially legal. You have to bring everything we have in the quality toolkit to bear to deal with this. As Warren Zevon says, bring lawyers, guns, and money. I want to just reemphasize one point. It's easy to think of the development of a predictive model as a data science project. But you can't do all the quality work that we've talked about here simply in that context. This has to be a whole company effort. Bring everything your company has to bear in dealing with data quality here. This is not simply a data science project. thank you very much for your kind attention, and please send along your questions.
Thank you so much for that enjoyable presentation, Tom. It's been very useful. Just a reminder to our guests, you can engage with Tom with questions and/or comments at his dedicated Slack channel. Thanks again, and enjoy the rest of Nexus 2019.